62. Page 62. All right, with these types of questions, I would start with a diagram of the area to be enclosed. Like, what does that even look like? Am I just fencing in a rectangular piece of property, or am I subdividing it into smaller pieces? What is happening here? Am I fencing in all 4 sides, or am I only fencing in 3 sides? Because that does make a difference. These types of questions will usually ask for the dimensions, so the length and the width. Let's highlight that because some students forget what dimensions are, right? I'm talking about the length and the width that would result in the maximum area to be enclosed. This type is more challenging than the other regression types as it will not give you a starting point. Here's the kicker. This type of question does not give you a starting point on your table, and that's frustrating sometimes. But I'll try my best to make it doable. You need to read the question carefully and create a diagram before you create a table. Here are some examples of diagrams. Okay, some examples. So let's say this is all just a rectangular piece of property. All sides are fenced in. So this is 2 lengths and 2 widths. Okay, so I would say in this case, the perimeter would be 2L plus 2W. Nothing new there. Everybody is familiar with that. Okay. So this perimeter really will translate within the problem as the amount of fencing available has to be spread out between 2 sides that are called the lengths and 2 sides that are referred to as our width. So that's how this scenario would play out. So it's important to create your diagram and then come up with this. The question will tell you how much fencing is available. Okay, it will say you have 1,000 feet of fencing available or whatever. And then next is this other example. So this is example number 2. There's an existing structure, so no fencing required. No fencing required on this one side. Okay, and so the perimeter in this case would be just length plus 2 widths. Okay, page 62. Okay, so the fencing would be length plus 2 widths in this case. That would be spread out among that. I will tell you this: if there's ever a section that is not fenced in, make that be the length of your lot. It'll just save you trouble. Okay, so make the widths be the cross pieces that are shorter, and if something is not to be fenced in, make that one of the length of this property. Okay, and look at this. So there's like a chicken coop or something. You're making many partitions, right? Subdivisions or partitions, right? And the assumption is they're all going to be divided equally. You can't do one bigger and one smaller, right? Every section has to be subdivided equally. Page 62. So that would be perimeter, and we're assuming everything gets fenced in. So the fencing available has to be spread out between 2 lengths. And this is where students get it wrong all the time. They make a perfect diagram, but they forget how many widths there are. So just count, right? 1, 2, 3, 4, 5, 6. This particular case, there will be 6 smaller cross sections that you need to account for that will require fencing as well. How many subdivisions have you created? 1, 2, 3, 4, 5. That's where students get it wrong. They go 5W because 5 partitions. Just draw out your diagram and just count how many widths there are. Okay, that's as easy as that. So fencing is therefore 2L plus 6W. No surprises there. That's a step. That's the first step. Create a diagram and come up with your fencing algorithm, your fencing equation that pertains to this particular situation. And then step 2 is write out the equation of the perimeter or area depending on what you're given. Okay. Isolate for length or width using the equation in step 2. I usually isolate for length. That's what I do. How is that going to work? Let me show you real quick here. So in this case, to isolate length here, I'm going to do it really, I have to shorten it. I can't show you step by step. I would say length is equal to fencing minus 2W because the 2W comes over. And see how the 2 used to be in front of it, so I would divide both sides by 2 to make this happen. So this is how you would isolate for length in that scenario right there. If you have this scenario right here, if you want to isolate for length, it's actually the easiest case. Length is equal to fencing minus 2W. That's all. This 2W comes over to the other side, subtracting. So there you have isolated length. And you'll see in a bit why we do that. If you're given this scenario over here, right, length would be fencing minus 6W divided by 2, right? Because I need to divide both sides by 2 at the end. Please don't forget that it's implied that you first perform the operation in the numerator and then you divide by 2, or else you're going to get the wrong answer. A lot of students just type it in all in one shot and then you get it wrong. So I'm going to go arrow up showing you that, right? That's what we've done in each scenario. We've isolated for length. You're not going to get all scenarios at the same time. It's going to be one of these, but there's many more possible. Next, create a table like this. Let the dependent variable be 100, 200, 300, or 50, 150, 200. And really, it doesn't matter. You can go 1, 2, 3 if you want. It's almost like, remember when you created a table of values in grade 10 in APMPR, you just put in a number for X and you figured out the Y. That's the same thing that we're going to do here. Okay. So which one is your dependent variable over here? Your dependent variable is W. Every single time, in this case, it's W. It's the one that's not isolated, right? Dependent variable is not isolated. Okay, that's a big note there. And then perform your regression using quad reg. Make sure your resulting equation does not have A equals to 0. It would be linear. And I will say this is always L2, this one right here. So just like the profit question where we had, right, the cost, the number of items, and then profit, in that sense, this is exactly the same once you fill in the table. I know it's a little bit overwhelming, isn't it? I'm fully aware of my time, so let's dive right in. I'm going to skip this graph here and just go right to page 63. you're a contractor and you have 600 meters of fencing available to enclose a rectangular area. So important things would be 600 meters of fencing. So that's how much fencing is available. The question will give you this. And what are you fencing in? In this case, it's just a rectangular area. There's nothing fancy about that. It is adjacent to an existing garage, right? So that's important. Adjacent to an existing garage, so no fencing required along that side. So read the question carefully. I'm going to walk you through it. The question may not do this, but let's sketch a scenario. So we have a rectangular property, and one side is not to be fenced in. Some of you might say, well, I'm just going to make it this side here. But I will tell you, always pick the long side as your non-fenced in area. No fencing, right? No fencing here. So that means that you're left with length and 2 widths. That's all. Those are the only ones that need to have fencing applied to them. B, so I'm basically walking you through my steps, guys. B, write the equation relating the dimensions and the perimeter. That's a fancy word of saying, let's do this. Perimeter would be length plus 2 widths. I got that from my diagram, my interpretation of the question. That gave me this. The perimeter is fencing, how much you have. So you substitute that. 600 is equal to length plus 2 widths. It doesn't ask you to do it, but you should isolate for one of them. Which one do I always pick? Length, because my keys are always like that, but it really doesn't matter which one you pick. So I'm going to say length is equal to 600 minus, because the 2 W's over here comes over subtracting like that. And here I have to caution you here. If this question had not indicated that there's no fencing required here, like you actually have to fence in all 4 sides, this would have been 2L plus 2W. 2L plus 2W, which would have meant that when you bring the 2W over, you would have still had to divide both sides by 2. If that had been the case, okay, don't forget that. In this case, L is already isolated. I'm going to box that in. That is really important. Really, really important. So you're basically relating the fencing you have with the dimensions that are present. So then we go length, width, and area. And area, remember, is length times width. I think I can make this work. Which one is my dependent? This is my dependent, right? So therefore, you assign values. You can pick any value you want. Really, Mr. Erickson, can I do negatives? You could. I wouldn't recommend it, but you could. I'm going to go with 20, 40, 60. So 20, what if the width is 20? What if the width is 40? What if the width were 60? So we're going to play around with values and come up with the one that would maximize the area you're enclosing. What dimensions would you have to use to get the maximum area possible? And there is such a thing, by the way. So if these are assigned, how would we find the length? The answer is, this is your answer right here, okay? So we would go 600 minus 2 times 20. Let's say the width would be 20. What would you get there? We'll figure that out in a bit. Next step, 600 minus 2 times, in this case I made the width 40, so I'm going to go 40. Next up, 600 minus 2 times W, right, which is 60. And so that's, you basically figure out length based on what you determine to be the width. Who picked these numbers? Mr. Dirksen did, but technically you should be picking them, right? You can go 100, 200, 300. It's up to you. Any numbers work. So let's go and do this. 600 minus 2 times 20, that's 40, right? So that gives you 560. 2 times 40 is 80, so that would be 520 if you subtracted that. And this would be 480 if you go 600 minus 2 times 60. And you guessed it, you would go 560 times 20. Here you'll go 520 times 40. And then you'll go 480 times 60. So for now, just maybe write this down. And so these are the resulting areas. Because remember, if you say, hey, I want the width to be 60, you are bound by this relationship, right, to figure out what the length would be. Okay. So 480 and 2 widths ends up still being 600 because you always have 600 meters of fencing available. Let's determine the equation. Determine the equation that relates the length and the area. So you need to put in length into L1 and area into L2. L1, L2. Let's go ahead and do that. And we're going to have to figure out our window, all that fun stuff. So stat edit. We go 560. 520, 480. Oh, sorry. Wrong column. Stat calc. Reg. You still have that probably. Let's graph it. Can't see anything, Mr. Dirksen. Okay, let's try zoom stat. You get the points on its way down. No problem. Go window, -5 for X min. I'm going to expand my X max to 800 because I still couldn't see the whole thing. Y min is -5. Y max, I'm going to go 50,000. And then hit graph again. And that worked for me. Here's the window again for you if you want to have the exact same window that I use. But I basically changed all of my values to make this work. So let's determine the equation. I need to run this again, sorry. Let's write that down. Second trace, no, stat calc. Stat calc quad reg y is equal to -0.5x squared plus 300x. Perfect. What would be the greatest area that can be enclosed? Remember, every single point right now is this, length and area, right? It's just like before it was price profit or number of items profit, whatever you ended up picking. So we're going to find the vertex right? We're going to find the vertex. Second, trace max. And let's go find the vertex. Trace max. 10. So there it is. 345,000. There it is, Mr. Dixon. Good luck with that, right? Greatest area is 45,000 what? Not meters, but squared meters, right? That is the greatest area that can be enclosed with the restrictions you have. And last but not least is the last little bit. What dimensions would yield the maximum area? I know that length is 300. How would you find the width without using another equation? You would just take your area and divide it by the length. So take the area you found and divide it by the length you found. So you're basically using the two values from your vertex to figure this out. And the answer is 150 meters. These are your dimensions. Okay. Dimensions of 300 meters by 150 meters will maximize area. Okay, for tomorrow's quiz, I will post a key. There's a review that goes over all types in your booklet. Just stay tuned on your Google Classroom. So tomorrow's quiz, basically just the regressions, okay, and word problems. Just focus on word problems and regressions, and you will be all right. I'll see you tomorrow, guys.